Okay, so our last kind of transformation is a shift. We can shift the graph up, down, left, and right. Okay, this is actually, in my opinion, the easiest kind of transformation to understand, but I'll leave that to you to decide. Okay, and so what we have here is we can have a positive shift, which would be up or to the right. Okay, if it's a vertical positive shift, it's an upward shift, up shift. If it's a horizontal positive shift, it's a right shift, right shift. Or we can have a vertical negative shift, which would be down, a down shift. Or we can have a horizontal negative shift, which would be a left shift. Okay? And so once again, with the vertical and horizontal, we can see that the transformation is happening either to the whole function or it's happening just to the x. Okay? And so here's the idea. An upward shift of the function f of x, so g of x would be an upshift of f of x if g of x is equal to whatever f of x is, and then just with a plus k, where k is a constant. K is just a number, okay? So like plus 5 or plus 300, okay? We could also have a downshift. G of x is a downshift of f of x if g of x is equal to the whole function f of x, and then with a minus constant. So with a minus on the end, and then whatever the constant is, like k. Let me write a couple of examples of this. So let's say that f of x is equal to 3x squared plus 2x minus 5. And let's say that we want g of x to be an upward shift by 17. So let's say g of x is going to be an upward shift of f of x, so it's going to be f of x and then with a plus 17. Okay? So what we're going to do is we're going to rewrite f of x. G of x would be f of x is 3x squared plus 2x minus 5, and then all we have to do is add 17 to that. And so that means that g of x is equal to 3x squared plus 2x minus 5 plus 17 is plus 12. And so where f of x is 3x squared plus 2x minus 5, g of x is 3x squared plus 2x plus 12. And so all the values of g of x are going to be 17 larger than the values of f of x. So for example, we know that, let's plug 1 in for x. Okay, so f of 1, 1 squared is 1, 1 times 3 is 3. 2 times 1 is 2. 3 plus 2 is 5, and 5 minus 5 is 0. Okay, so f of 1 is 0. Well, let's see what g of 1 is. Okay, well, if I put a 1 here, 1 squared is 1, times 3 is 3. 2 times 1 is 2, so 3 plus 2 is 5, plus 12 is 17. And so sure enough, f of 1 is 0, and g of 1 is 17 larger than 0, so g of 1 is 17. We could do the exact same thing with a negative shift. We could have put minus 17 here, minus 17 here, and negative 5 minus 17 would wind up being negative 22. This would still be f of 1 is 0, and we'd have 5 plus 5, 3 plus 2 is 5, and 5 minus 22 would be negative 17. And so either way, it works out, okay? All right, so now let's look at a horizontal shift. So g of x is a right shift of f of x if g of x is equal to the function f of x, but the x's are going to have a factor, we call it h, subtracted away from x. You may wonder, why is a positive shift associated with x minus? Well, I'll show you a real quick example. When we have, let's say, x minus 3, if we were to write that on 0, so set it equal to 0, to solve for x, we would add 3, and we'd have x is equal to a positive 3. So x minus 3 results in x equals a positive 3 shift, okay? And so with the horizontal shifts, we actually use an opposite sign. If g of x was going to be a left shift of f of x, then g of x would be f of x plus h. And so let's use that same example there. Let's do a rightward shift by 4, okay? And so if f of x is 3x squared plus 2x, minus 5, okay? Then then g of x would be equal to f of x minus 4. That's a rightward shift by 4. And so g of x would be equal to 3 times x minus 4 squared plus 2 times x minus 4 and then minus 5. So notice it's a composition function here. In the place of x, we're putting in x minus 4. So we get this x minus 4 and we got this x minus 4. Now I'm not going to expect you to simplify this, to expand it, okay? You don't have to convert this, you can leave it as is. But this would be a rightward shift of the f of x curve. We could also do, what if we wanted g of x to be a leftward shift? Let's say we wanted g of x to be f of, let's shift left by a factor of 9. So we can put x plus 9, f of x plus 9. And so then g of x would be equal to f of x, but in the place of x, we're going to put x plus 9. So we'll have 3 times x plus 9 squared plus 2 times x plus 9 and then minus 5. And so this would be the leftward shift by 9. Okay? And what we'll do now is we're going to go over to Desmos and we're going to see examples of this. We're going to take that same graph that we've looked at a few times and we're going to shift it up, we're going to shift it down, we're going to shift it to the left, and we're going to shift it to the right. Okay, so here we are again with this same function. Here's our, and we got x minus 2, x minus 1 times x plus 2 times x plus 1. And so let's say we want to do a vertical shift. Well, if we want to do a vertical shift, all we have to do is, let's say we're going to shift it up by 3. So all we have to do is add 3 to the end here. Just add on a plus 3. This is f of x. Then we just put on plus 3. Well, if you come down here, you can see I've already set that up. Here we have the regular function, and then we have plus 3. So if I activate this, you'll see that it's the same graph, just shifted upward. Okay, and so what about a downward shift? Well, we could shift down by 3 if I just put a minus 3 on the end of it. And if I activate this, you'll see there it is, shifted downward. So now let's say that I want to shift it to the right by 3. Well, to do that, I would have to put a minus 3 on every x. And you can see here, I've put in x minus 3, then minus 2. I've replaced the x minus 2, but I've replaced x with x minus 3. And here, I've replaced x with x minus 3. Once again, here, I've replaced x with x minus 3. And on the last one, you can see I've also replaced x with x minus 3. So all 4 x's are replaced with x minus 3. And so when I activate it, you can see that it's shifted over to the right. Okay? And then we can also do a leftward shift by 3. And in order to do that, I have to replace all the x's with x plus 3. So here, in place of x, I have x plus 3. Here's another x plus 3. Here's another x plus 3. And then all the way over, you can see this last one also has x replaced with x plus 3. And so when I activate this one, you will see that it is a shift to the left. It's hard to see, but let me turn off the original, and you can see that it's shifted over to the left. Okay? And so that is up, down, left, and right shifts, and that should be pretty easy. And what I'm going to do now is maybe one more video just with a bunch of examples of varying kinds of transformations.